Alrighty, in this video we are going to be talking about animations. So animations in Unity are actually incredibly powerful and allow us to manipulate any property in a Unity game object over time, including its children. We can actually do a lot of amazing stuff with animations without even having to touch a single line of code. Let's go over some of the things that we can do real fast with some really basic examples. We're going to be working our way up to the player, because the player is going to require quite a few of the different features of animations to make work properly. But stuff like the buzzsaws and the cannon and the stars and the health pack are all going to be pretty straightforward. Okay, so let's go ahead and start with the buzzsaws. So I'm going to move these stars up here, and I'm going to go open up my prefabs folder, and I'm going to drag over in a insta-kill buzzsaw. And I'm going to bring him in right here so that we can animate him and we can see him be animated over here visibly. And then when we actually place him in the level, we'll place him out behind, obviously when we place him in the level, we'll be placing him behind different bits of objects. Okay, so to add an animation to a object, we have to go to the animation window. This window right here is next to my console, but to access it, we'll go up to Window and then Animation. Now, animations are basically just these little files that describe the change of a property over time. The change of a property over time is called a curve. An animation can contain multiple curves. An object can contain multiple animations. So there are two primary components that we need to discuss: the actual animations themselves and the animation controller. Now, fortunately, the buzzsaws are not going to have a very complicated animation controller, so we won't have to look at that quite yet. But when we get into the player, we'll definitely have to look at how we can manage different states of animations at different times. So let's go ahead and just make this buzzsaw rotate. I think that's the simplest animation that I can think of, and it'll provide a really good introduction to how to work with the interface for adding curves. So what I'm going to do is I'm going to make sure my insta-kill buzzsaw is selected. Then I'm going to say add curve. When I hit add curve, it's going to ask me to save a new animation file. Now, this animation file is going to be a container for multiple curves, where a curve is the change of a property over time. So what I'm going to do is I'm going to create a new folder, and I'm going to call it Animations. Inside of Animations, I'm going to call this, let's call this Buzzsaw Rotate. And I'm just going to hit Save. Now, when I hit Add Curve, after it adds the animation, it's going to do a couple interesting things. It's going to add an animator component, and it's going to ask me which component do I want to animate. Now, we can click off this window, and we can click Add Curve again, and you notice it doesn't ask us to add an animation again. That's because we now have Buzzsaw Rotate selected in our animation window. If we click on this, we will see a list of all the animations available on this object, as well as an option to create a new clip. So a clip is a collection of curves. So let's select Buzzsaw Rotate, and let's say Add Curve, and let's go ahead and select one of the things we want to animate. Now, you'll immediately notice that not only can we animate any property that supports a particular type on our object, but we can also animate the child objects. For example, I can animate whether the path definition script is enabled. I don't know why I would want to do that, but I can. The point is that you ever have a property on one of your mono behaviors that you want to change over the course of time, you could do so with the animation system. You can just come here, pop in a curve, select that property on that mono behavior, and you can animate it over time. It's a very powerful feature. But what we're going to want to animate in particular is the blue saw and his transform, and then inside of his transform, his rotation. So I'm going to click the little add button. Now what we'll see right here is, since we have the dope sheet selected, we will see a timeline combined with keyframes. This is a very similar concept to any other animation package that you might have worked with, including, for example, Flash. So our dope sheet allows us to scrub, so we can scrub through our animation, and it also allows us to place keyframes. You'll notice a couple other things that are interesting about this interface. I'll go ahead and expand it so we can take a deeper look at it. You'll notice that we can expand our transform and we get the individual transform components, our rotation Y, our rotation X, and our rotation Z. You'll also see that there's a number right here. That's the value of that particular object at that particular time. So let's go ahead and just make it spin. How do we make it spin? Well, let's select all the way over here on the right hand side at about 1 second. We're going to go ahead and select these keyframes, and I'm going to add a parameter in right here on my, I think it's my rotate Z. Yes, my rotate Z that I want. So I'm going to come in here and rotate Z, and I'm going to type in 360. So now watch what happens while I scrub through the animation. You'll see that our buzzsaw rotates. Remember, we want to add the animation to our insta-kill buzzsaw, but what the object that we want to animate is the buzzsaw or blue saw child, which you can see represented right here, our blue saw transform and specifically his rotation. And now you can see that our animation is already there. If we hit the play button, we can watch the animation continuously loop, and that's really cool. So what about some other things about this animation? Well, first of all, there's something called the record mode. The record mode is a really awesome feature of Unity, where you'll notice that this little record button is clicked in. And it's red. We can enable and disable the record mode by just clicking on this little red button. You'll notice that when we're in record mode, our play buttons turn red. In addition, any property on this object that we're animating is also turned red, indicating that we're manipulating that value over time in our animation. In addition, there's some other cool stuff with record mode. First of all, if I wanted to, for example, set his scale at 1 up to his X scale to 2, watch what happened when I did that. All I did was I typed in 2, and now we actually created a whole new curve. Unity automatically noticed that we had manipulated a property that was animatable inside the game object and automatically created us this curve that allows us to manipulate it. So as you see, we are now manipulating both the scale and the rotation. A couple other cool features about the record mode is I can auto add in keyframes by just coming in here and changing one of these values. For example, maybe at halfway in, I want to change the scale down to 0 for whatever reason. You'll notice that we now have a new keyframe that was automatically brought in for us. So if we hit play, we'll see that the buzzsaw is scaling and rotating, and that's really cool. We could also add keyframes in by clicking this button, Add Keyframe, and that'll add a keyframe into our timeline as well. So this is the dope sheet. I'm going to go ahead and delete the scale curve because I don't want to do scales. I just want to do rotations. Let's look at the curves. You're not going to be spending a whole lot of time in curves, but what you can do is you can select one of these values and you can see how it interpolates from its first value to its second value. So you'll notice right here we have a basic linear interpolation where it goes straight from one value to the next value. But there's a lot of additional power we have in this system. For example, I can come in here and I can move this curve around, which will make it, as you notice, it starts moving quickly and then it ends moving slowly. I can move this curve down here and you'll notice it kind of swivels back and forth, then it goes all the way back up, and so on. I can also add additional points in this if I wanted to by double clicking. And we can see that now it kind of goes back and forth and back and forth. In addition, I can click on one of these curve items, right click, and say something like, let's do free smooth, where now we have Bezier curve handles that allow us to manipulate how we want the curve to look in the things visually. So for example, I can make it look like that, Or I can make it look like that, which will be really crazy. It just, yeah, it's barely even intelligible as far as what it's doing. Or I can make it, a little bit more sane by maybe having it look a little bit like a sine wave there. The point is that we can come in here, we can play around with this stuff. Obviously, this isn't a video series about animation. Animation in itself is a very, very involved topic and requires a lot of practice in order to get good at. You won't be surprised to hear that I am also, in addition to not being a level designer, a sound designer, I am not an animator. So it's really going to be limited by your imagination.
We'll make do nonetheless.
Yeah. It's really limited by your imagination once you understand the tools, and further, it's going to be limited by your proficiency with working with the concepts of animation. But that's what's great about it, because it's so powerful. It allows us to animate almost any object. We can come in here, we can manipulate the curves, or we can look at a more traditional dope sheet if we want. It allows us to really express the kinds of animations that we would want really, really quickly. So this is just an introduction to basic animations, but there's a lot more fun stuff we can do. Even before we get to the player, which is arguably the most complicated bit of animation logic in our game, we'll also in this video get to see how we can do things like events and how we can handle things like triggers. Okay, so let's go ahead and I'm going to clear out this animation entirely, so it's just one keyframe, and then I'm going to come up to about 30, and I'm going to set its Z to 360. This will make it spin. I think my curve is linear, which is exactly what I want. This might be a little bit too fast. There's a couple ways to slow it down. One way is to change the sample size. Another way is just to marquee select these keyframes and move them over. I think that looks really good. Okay, so let's talk a little bit about what else adding a curve to this object did, because it did not only just create an animation. If we open up our animations folder, we see two things. We don't just see one thing, we see two things. We see buzzsaw rotate, which, as you see over here on the left-hand side, is indeed the name of our animation that we've been creating, but we also see insta-kill buzzsaw. What is this? This is an animation controller. The animation controller is responsible for knowing which animations to play at which time. We'll be looking a little bit more at the animation controller later in this video, but for now what we can see is just visually we can see that buzzsaw rotate is the default animation for this object. Therefore, it will always be in buzzsaw rotate. So we see that it created an animation and an animation controller, but it didn't stop there. It also added the animator component to our object, and it set the controller to our controller. All the other options are irrelevant. We're not going to be worrying about those other options in this video series. For now, the important thing to understand is that the controller is responsible for knowing which animations to play, and the animator component is responsible for hooking an object up with a particular animation controller. Given all of that, all we have to do is hit apply, and we've now applied this animation component, or the animator component, with the corresponding animation controller. We've now applied that to every single insta-kill buzzsaw. Meaning I can move this buzzsaw in right here, I can duplicate it, I can move another one in right here, I can duplicate it again and add another one in there. And when I hit play, we now have rotating buzzsaws. Okay, I'm getting distracted now. Alright, so that is the basic introduction to animation, where we only have one animation that is looped continuously and is applied to multiple objects. Let's go ahead and look at a slightly more complicated animation. I want this cannon to change visually while it shoots an object. So what do I mean by that? Well, I want it to be idle for most of the time, just kind of sitting there. But when it shoots an object, I want it to kind of squish in and then push back out. Kind of look like it's shooting an object, kind of in a cartoony-ish way. What we're going to need to do is we're going to need to create two animations, one animation controller, and we're going to have to modify our code to tell the animation controller when we fire something so that the animation controller can perform what is called a transition. And the transition will tell the animation controller to go from the idle state to a firing state, and then I'll create another transition that'll have it automatically loop back from the firing state back to the idle state. So let's go ahead and do that. Let's come up here, let's click on our cannon. I want to click on the parent object here. No, actually I don't. I want to click on, I want to click on the cannon. What I'm going to do here is basically we're going to have the animations applied to the cannon object. Then the projectile spawner object will be responsible for telling the cannon animator when it is firing, and we'll do that through a reference to an animator in our pathed projectile spawner, just like how we did with our spawn effect, for example. Or our spawn projectile sound. However, I do really want to change up this prefab a little bit so that the sprite renderer is a child of the cannon. Why would I want to do that? Well, like I said earlier, I want this cannon to squish. I want his scale to get smaller when he's shooting. Watch what happens when I squish him. Do you see that? His target point moves because we're scaling the whole object. And the object includes its child objects. And what's a child object of cannon? Destination. So this is not ideal. What we want to do instead is we want to go ahead and create a child component of cannon that will contain the sprite renderer so that I can manipulate the sprite renderer independently of the other objects that are childed to it. So I'm going to come up here to game object. I'm going to create empty. I'm going to drag this empty game object into our cannon, and I'm going to call it cannon sprite. Then inside of this cannon, I'm going to do a little bit of Unity magic. I'm going to click and drag right here on sprite renderer. Just click and drag, and I'm going to dump it. It's not going to let me do it. It's probably not going to let me do it because it is a prefab. So unfortunately, we won't be able to do it that way. So what I'm going to do instead is I'm going to remove the sprite renderer from the cannon component, and then I'm going to add it back into the cannon sprite. I am also going to do all of this translation at the origin. The reason I'm going to be doing it at the origin is because we're editing a prefab with a child in it. So I'm going to switch this prefab over into the origin, like so. Then I'm going to come up here and say remove component on the sprite renderer. Then I'm going to click on the cannon sprite, and I'm going to orient him at 0, 0, 0 with a scale of 1, 1, 1. I'm going to add a component called sprite renderer. For the sprite, I'm going to click on that little targety circly thingy, and I'm going to click on cannon. Close out of that. Set the sorting layer to foreground. Set the order layer to 3 like what we had before. Then I'm going to click on cannon and I'm going to hit apply to apply that change to the entire prefab. Again, the reason I did this was so I can manipulate the scale of the sprite without manipulating the whole prefab. Okay, so let's take the cannon and let's place him all the way back where he was previously. I think that should be fine. Okay, let's go ahead and add an animation and an animation controller to cannon. I'm going to select add curve. I'm going to open up animations, and I'm going to call this curve cannon idle and hit save. I am not going to add anything else to it. Canon idle will be an empty animation. But what happened was that Canon now has an animator, he now has a controller, and he now has a Canon idle. Let's go ahead and create another clip. So I'm going to come down here after selecting Canon. I'm going to say Canon idle. I'm just going to say create new clip. I'm going to go into animations and I'm going to say Canon fire and hit enter. It's important to understand one quick thing. Before we move on, it's important to understand one key concept here. In the animation window and in the animator window, we are not modifying this object. We are modifying this object. We are modifying the animation controller and the individual assets. However, with Unity, when you want to work on the animation of a prefab, you're going to have to instantiate that prefab to work with it in the editor. But the changes you make to the animation window and the animator window are going to apply to the asset that is shared between all of the instances of that prefab. Therefore, you'll be able to just drag a prefab in, work on its animation, apply the changes to the prefab, and then delete it, and those animations will be present on every subsequent prefab that you generate from it. Okay, so let's work on our Canon fire. Now, we haven't talked about how the Canon fire animation is going to happen yet, who's going to trigger it, but that doesn't matter at this point. At this point, all we need to worry about is creating the actual animation. So I'm going to scrub to 0, and I'm going to add a curve, and I'm going to add a curve to Canon Sprite, Transform, Scale. Then at about 2, I'm going to come into the Canon Sprite, and I'm going to change his scale down a little bit. And then I'm going to have it go down, and then back up, and then a little bit back down, and then back to normal again. All right, I think that works, but it's a little bit too slow for me. So I'm going to condense the keyframes a little bit. This might be hard to see on video, and I know for Steve it's probably impossible to see, but I need to make it a little bit faster. Okay, maybe if I bring...
Yeah, I can see it just in chunks.
Maybe if I bring these keyframes in a little bit. Yeah, I think that'll work. Again, I'm not an animator, and I'm really just wanting to show you guys the tools. I could spend hours playing with the animator just like I can spend hours playing with the particle effects. Again, this is not a video on animation. This is a video about the Unity tools that allow us to express animation. Okay, so let's go ahead and hit play and see what happens. Nothing. The Canon is still pretty boring. The reason for that is the animator window, or the animation controller. So the animator window is accessible from Window Animator. So remember, you have Window Animation for your curves, your dope sheet, and your dope sheet, and then you have Window Animator for your animation controller. So I'm going to move these states around a little bit. So we'll have Canon idle and Canon fire. I'm going to play the game, and I'm going to switch back over to the animator. Unfortunately, it's not going to... Here we go. If I click on Canon, what do you see? You see the Canon idle is sitting there looping over and over and over again, and it's never getting to Canon fire, so it never procs that animation. What we need to do is we need to create a transition from Canon idle to Canon fire. Now, the transition system in Unity is pretty powerful, but it's also incredibly simple in cases where we just want to have something happen or be triggered at certain points of gameplay. So what I'm going to do is I'm going to add a parameter. Over here on the bottom left-hand side of our animator, we have this parameters window, and I can go ahead and click this button, and I can add a float, an int, a bool, or my personal favorite is a trigger. So we're going to click on trigger, and I'm going to call this trigger fire. So what is a trigger parameter? Well, a trigger parameter is a parameter that can be set by code. Think of it like a one-shot Boolean. So you know how a Boolean can be true or it could be false? Well, a trigger is like setting a Boolean from false to true, but only once. It'll only trigger those animations, those transitions that one time, and then that trigger will reset back to the false value. Okay, so we now have fire defined as a parameter. Now we can use it to create a transition from cannon idle to cannon fire. To do that, let's right-click cannon idle and say make transition. Now you'll notice nothing happened when I did that, but actually if you move your mouse out, you'll see this cool little arrow thing up here. So I can take this arrow out and I can just click on cannon fire, and I've created a transition. Now just by creating a transition, if I come back here, you'll notice cannon idle executed and then it went to cannon fire. Now that's not exactly what we want. We want to limit the transition to only happen when the fire trigger is set by code. So what I'm going to do is over here in my conditions is instead of setting an exit time to 0.75, I'm just going to click on fire. Fire happens to be available to us because we created that fire trigger in our parameters window. Okay, so now we've created we've now created a trigger, and we've created an animation that takes advantage of that trigger. But we haven't actually told Unity when that trigger happens, or when that trigger should happen. The way that we do that is we go into code and we reference this object right here, this animator object, and then we invoke a particular method on it. So what I'm going to do is I'm going to open up my projectile spawner class. So I'm going to go into Visual Studio. I'm going to locate my projectile spawner. Oh yeah, I called it path projectile spawner. And then I'm going to create a public field, and I'm going to say public animator. So this will be a field that I can set on my projectile spawner to be an animator that should respond to a fire trigger whenever the projectile is fired. So now let's go and scroll down to our update method, to the end of our update method, and I'm going to say if animator does not equal null, meaning if somebody set an animator to something in the inspector, I want to say animator dot set trigger fire. So what'll happen is if animator is not set to null, it'll set the trigger fire every time the path projectile spawner fires a new projectile. Coming back into Unity, we can click on our project spawner, and now we see the animator parameter has appeared just like we put it in code. Now let's click and drag cannon into that animator. What we've done is we've associated the animator in our parent cannon class, or cannon object, to our projectile spawner. So now this animator will receive a fire trigger, and it will cause this transition to happen. So before we forget, I'm going to click on cannon and I'm going to hit apply so that our animator gets added to our prefab, and so does our projectile spawner animator's property. Now let's hit play and see what happens. Okay, so we saw that the cannon sat there for a while, idle, just like what we want it to, and then it's going to fire something, and then it just starts wigging out. So what's going on? Well, let's go ahead and hit play again, but I'm going to quickly switch over to the animator window. What happened is it hit that trigger, that fire trigger, it went into the cannon fire state, and then it just sat there. So let's go ahead and make a transition back from the cannon fire to the cannon idle when the cannon fire is finished. So let's make transition from cannon fire back to cannon idle. And let's take a look at how we can manipulate this to do what we want it to. Basically, we want to go into cannon fire, have it play once, and then go back to cannon idle. What we want to do here is we want to set our exit time on this transition to 1. What does that mean? Well, it means, as we can see right here on our little scrubbing thingy, we can see that the cannon fire will play in its entirety, and then once it's totally done playing, its exit time is 100%, it'll move back into the cannon idle. Let's go ahead and see if that works. Indeed it does. And we can verify it working too by going into the animator and seeing that the cannon fire does execute, and then it goes back to cannon idle. Alrighty, so I think that's pretty much all I wanted to do with the cannon. It looks like it's kind of wigging out right there a little bit, but again, I'm not an animator, so I'm not going to worry too much about making the animations perfect. There's a lot more stuff you can tweak in with this animation system. We can describe to Unity how we want these animations to blend in with each other during the transition and all of that fun stuff. But I'm just going to leave that as it is right now because this will serve our purposes. Alrighty. There's one thing that I haven't pointed out yet, and that is our cannon idle is orange. It's orange because it's the default state. That means it starts at this state. If we right-clicked cannon fire, we could set it as default by right-clicking setting as default, and you see that cannon fire becomes orange as well. So let's go ahead and make sure that cannon idle is orange though. Okay, so I think that's pretty good. We have our buzzsaws rotating, we have our cannon squishing. Let's work on our stars a little bit, because our stars and our health packs are going to be a little interesting. They're going to be interesting because I want an idle state and a collect state for both the stars and the health packs. However, if you recall, when we collect a star, it will be set to be disabled. As you can see, jumping back into Visual Studio, if we open up our point star, we'll see that it becomes inactive when it gets collected. Well, that won't do for us because what we want to do is we want to play an animation when the star gets collected and then only make the game object inactive when that animation has finished. So let's go ahead and start with just the basics. I'm going to go ahead and create the animation for the stars. I'm going to go ahead and create the idle animation, and then we'll create the collect animation, and then we'll work on our transitions, and then we'll fix up our code. So in the point star, I'm going to select the main point star, and I'm going to say add curve, which is going to require that I create new animation, and I'm going to do so in the animations folder, and I'm going to call this star idle. Okay, the star idle, I'm going to select the star child object. I'm going to select its transform, and I guess we can just select its rotation, and then I'm also going to add a curve for its transform scale. So what do I want it to do? Well, at about halfway in, let's see. I wish I was an animator. We can rotate it a little bit. So we start about, we can start 45 degrees rotated on the left, and then we will end negative 45 degrees in the Z. And then we'll get, well then after we do that, we'll have to do another keyframe at about, so we'll start there, we'll go to that side, and then we want to end at about, let's see, at about, that's 30, so at about 60, we'll end by setting it back to 45 degrees. So it'll kind of wiggle back and forth. Then for its scale, we'll make it get a little bit bigger when it's in a little bit bigger here by setting its scale, maybe its scale to 1.5, 1.5, and then have its scale drop back down to 1 and 1. What do you think, Steve? Maybe that's too much scaling.
Put it together.
I think that's too much scaling. Let's come back here into the 30 and change the scale to like 1.2, 1.2. We want it to be as subtle of an effect as possible.
Is it at 1 when it's at each of the 45 degrees?
Yeah.
My latency is too bad to tell.
It resets back down to 1 when it's at each of these.
Yeah, I like that.
Okay, maybe we can slow it down just a tad. We can slow it down a couple ways by changing the sample size or by increasing the length of the keyframes, which I typically do. There we go. Okay, so now that we've done that, let's go ahead and hit apply for our point star. So I'm going to hit this apply button at the top right and then hit start and see what we get. Okay, I think that looks good. So now what I want to do is I want to create another animation for when it gets collected. I kind of want it to float up and disappear. So let's go into here on the animation, say create new clip. And I'm going to go into animations and I'm going to call this star collect. Star collect, I'm going to add a curve for the transform of this pair of the child star. And I'm going to grab his position. Then I'm going to hit add curve, go to the child star, select the sprite renderer, and add the color. For the color, I'm going to expand the color. I'm going to go all the way to the right-hand side, and I'm going to select the alpha as 0. So this will make it fade. Maybe that's a little bit slow. We might want to do it up at maybe 40. So that'll make it fade. So as far as the star's position, because this is a child game object, we can just come up here and we can change the Y and have it just float up. So change the Y to like have it float up 4 units, I guess. All right, I think that looks good. Again, I don't want it to go too crazy with the animation because I know I can, but we will have a nice, really straightforward collect animation just to show the process. Again, I'm wanting to show this because this is going to be slightly more complicated than what we had with our Canon. So let's jump into the animator and create our transitions. Just like the Canon, we're going to go from star idle to star collect. And what I'm going to do is I'm going to say star idle, and well, before I do that, I'm going to hit this plus button on parameters and add a trigger. And I'm going to call this collect. And then from star idle, I'm going to make a transition to star collect. And I'm going to click here and I'm going to set the condition to collect. Then I'm going to make an animation from star collect to star idle. And the condition will be, that's fine, exit time 0.63, whatever. That's fine. So now what we need to do is we need to transition from star collect or star idle into star collect by hitting the collect trigger, and then we'll automatically go back into star idle. So how do we do that? Well, let's jump into the code and let's open up our point star, and I'm going to add a public animator. Now we have a problem. I'm going to go ahead and move the GameObject.setActive to the bottom of this method so that we can just work on the bottom of this method without having to insert code in the middle. But we definitely have a problem. We're setting GameObject.setActive false. That makes the object disappear, and it'll also mean that the animator is no longer active. So that's not what we want. Instead, what we want to do is we want to start the animation by triggering collect, then we want to wait for the animation to finish, then we want to set active to false. So there's a couple ways to do it, but the easiest way is for the animation to actually invoke a method on point star when it's done or when it reaches a certain part of the animation, which is a really cool feature. However, because we're not setting the game object to active false, when we're still active and playing our collect animation, our onTriggerInter method can still be invoked by our player, meaning a player could collect a star multiple times. So what we're going to do is we're going to keep around a Boolean indicating whether or not the star has already been collected. And I'm going to name it private bool is collected. Then on onTriggerInter, I'm going to say if is collected return. Then, when we collect the star, so I'm going to do this right after we set the floating text.show, I'm going to say is collected equals true. And finally, when the player gets respawned, we want to set is collected equals false. Now, instead of setting GameObject.setActiveFalse, we can say animator dot set trigger collect. Now we have one more thing to do, and that is we need the ability for the animator to actually invoke a method on this mono behavior. Again, this is a really cool feature of the animation system. So what we want to have happen is when the animation is done, we want this game object to be set to false. Easiest way to do that is to come up here and say public void finish animation event and have game object set active set to false. So we just have a method called finish animation event with game object set active false. Now, this doesn't actually do anything yet because we haven't told Unity to invoke this method, but we had to make the method first before we could tell Unity to invoke it, as you'll see in a moment. So in reality, the last thing that we have to do to make this system work is to go back into Unity, into our animation, and change it so that it invokes this method when it's done. To do that, we jump back into Unity, we go into our star collect animation, we go all the way to the end of the animation, and then we hit this tiny little button right here on the right hand side. So it's underneath the animation thing. It's to the right of adding a keyframe, which is on the right hand side of the same toolbar that has the record and play buttons. It's called add event. And I'm going to click on that, and then it's going to ask me for a function. What I can do is I can actually put in a function invocation to any of the functions that are defined in my mono behaviors. In this case, we get finish animation event, which is why I said that that we had to write it first inside of Visual Studio for it to show up in Unity, because we have to select from this dropdown. So I'm going to select finish animation event, and that's that. I can close out of the animation event. We'll see right here that indeed this animation, it does have an event. Visually, we can see it right here as this little bar right here. And if we hover over it, we'll see it says finish animation event. Alrighty. Now what we have to do is go into our point star, whichever one that we've been adding that animator to, like this one right here, and we need to reference this animator to our point star script. So I'm just going to click and drag on animator and drop it on the animator button, or the animator option right there on our point star. Now I'm going to hit apply to apply this to all of our stars. Now I'm going to go ahead and hit play. Okay, I really have to get rid of that buzzsaw, otherwise I'm not going to be able to hit that point. Alright, that buzzsaw is deleted. Let me go ahead and... I'm actually going to come in here and I'm going to duplicate a couple of these so I can test the effect. So I'm going to hit play. Seems like we might have a bit of a bug here. Let's see here. Let's go ahead and restart. Okay, we're getting a slightly unintended effect that I actually really like. If we restart, you'll see that the stars will actually come up and they'll drop down. That was completely unintentional on my part, but the reason why that's happening is because in our animator, we see that in the transition back from star collect to star idle, we see that it actually fades back into star idle. We can change that by changing these little sliders here. But I kind of don't want to change those little sliders. What we get instead with this way is we will slowly start to transition back into star idle when we get from star collect to the end of it, which is a really cool effect actually, because it makes it look like the stars are going up and fading, and then they drop back down. Now in this case, it looks like what we have here is, in certain scenarios, it doesn't really like us very much. Alright, let's take a look at why some of the times our stars are just sitting there and not going away. I think that the cause of that is probably because we have a very, let me see, I'm gonna make the inspectors a little bit bigger. There's a chance, I think, that it's not hitting that event, and if we zoom all the way in, we see that it's possible that the whole animation hasn't played yet. And if the whole animation hasn't played yet, based off of our frame rate, then we won't hit that event. So what I'm going to do is I'm going to cheat. I'm going to move over so it restarts the star collect animation just at the end of it. The idea here is that what's going to happen is it happens less frequently now. The animation is being hit more frequently, and there's less of a possibility of a mistake. Alright, let's figure this out. Okay, it seems that there's going to be a problem that is, unfortunately, it seems to be a bit like an unavoidable issue for now with the tools that we have available to us, at least the tools that we've gone over in video. So, in the interest of making this as simple as possible, instead of having our state transition back into star idle, which is causing a problem because it's not always hitting, as we can see here in our animator, it's not always hitting this event. And this event is what's responsible for setting our game object to be inactive. So because it's not always hitting that event, not all of the stars are becoming inactive, which is causing a problem. We can actually kind of fudge our way around this issue. Instead of having to worry about blending between multiple animations. And I will point out this, the issue only presents itself when I'm recording. I'm not even kidding, guys. Like, this isn't me being like, oh, this worked off screen and now it's working on screen, or it's not working on screen. Like, trust me, I know what I'm talking about. No, I'm actually totally serious. The recording software that I'm using is bringing my frame rate down just enough to where this problem is happening with a significantly larger frequency than it happened off screen, which was 0. So, let's go ahead and fix it. The way that I'm going to fix it is, instead of having the transition back from star collect to star idle be handled by an exit time, I'm going to add a new trigger. I'm going to go ahead, add a new trigger, and it's going to be called trigger, and it's going to be called, reset. And then my transition from star collect to star idle is going to have a condition of reset. And then when I come back into Visual Studio, when I hit the finish animation event, I'm going to say animator set trigger reset. And that should bring us back into the idle idle animation. All right, let's come back into Unity and hit play and see if we get the behavior we're looking for. Okay, so it looks like that's all good. Let's go ahead and kill ourselves and make sure that... Okay, so our stars are not resetting, unfortunately. Of course they aren't. Alrighty, so what I'm going to end up doing here is I'm going to go ahead and just make not the entire game object go away. I'm simply going to make the renderer be disabled. So the child object is what I'm going to set to inactive. The parent object will still consider to be active, which means that when I set the trigger to reset back to star idle, it will be allowed to perform that transition. So to do that, I'm going to come back here into Unity. On my point star, I'm going to say public sprite renderer. So I can add a renderer component. And then instead of setting GameObject.setActive false, I'm simply going to do renderer.enabled equals false. And then on my onPlayer respawn in this checkpoint, I'm going to say renderer.enabled equals true. All right, now I'm going to come back into Unity. I'm going to select one of my stars, and I'm going to click and drag the star object into the new renderer parameter, and I'm going to hit apply. Then I'm going to hit play. And we see the stars do indeed disappear, and if we die, they should reappear with full functionality. And indeed, they do. So I think that's going to wrap up our star implementation. Let's go ahead and just run through this process again real fast with our health packs. So I want to just basically apply the exact same animation and the exact same process to our health packs so you guys can see the process again and we can have our stuff nice and animated. Because I'm looking around, really the health pack and the player are really the only two things left to animate, in my opinion. So let's go to the health pack and let's add a new curve. Let's go into animations and let's call this health pack idle. And I'm going to grab the health pack object and let's set its transform. I don't know, let's make it wiggle back and forth. So I'll come in here, make sure I'm recording. Let's move it to the left a little bit. So that'll, or whoops, sorry. I don't want to move the parent game object. I want to move the child game object. So I want to move him to the left by like maybe 0.2. And then I want these keyframes to be at the beginning. And then I want him to move to 0.2. I want that right about there. So -2 to 0.2, and then let's come here and set it back to -0.2. Actually, I think that would look better in the x-axis, or the y-axis than the x-axis. So I'll just grab these values and set them to the other one. All right, sweet. So let's go ahead and on our health pack, let's click on the main health pack object and hit apply, which we can't do because we're in record mode. Go out of record mode, now hit apply, come back into our game, and our health packs kind of bounce up and down. As far as collecting them, I think I'm just going to go ahead and leave the green particle effects. I think that looks good enough. Again, this is definitely stuff you guys can play with a lot. I mean, there's a whole lot of possibilities for creating other kinds of animation and complex interactions between animations. But I think this pretty much wraps up everything that I wanted to do as far as basic animation. Now we're going to be building off what we learned in this video in the next video when we make a more complex animation with our player. So we'll see you guys in the next one.